Hello everyone, karibu sana to today's session. So we'll just take a minute to allow more people to join in. Then we can kick off at around 6:02. Hello and welcome once again. I'm your host and moderator for the evening. My name is Jessica Mbeka, Senior User Experience Researcher, Twiga Foods. Feel free to drop your comments, say hi, want to say hi. Hi, Jean, John, I hope it is. Thank you so much. Thank you for joining us today. So we're just spending the first few minutes to allow the rest to join us. But as we begin, I'd like to appreciate all of you for taking time this evening to join us for our maiden Twiga Tech Talks webinar. Yes, this is the first, and we are really excited. Maybe also a bit, just a bit nervous, not too nervous, just a bit. We're hoping that what we anticipate the session would be, maybe just a background on this. Uh, the concept behind Twiga Tech Talks is that it would be a regular webinar event where the Twiga Tech team would be able to share knowledge on how we use tech to create positive socio-economic impact. I know quite a number of you are familiar with our products. You're quite familiar with the work we do. You're quite familiar with the impact that Twiga has been able to create within the space which it operates. So we hope that these sessions would be able to drive value to you as well as professionals within the tech space, and also for the young professionals who are hoping to grow their skills in different topic areas within the tech space. So maybe just a bit of housekeeping. We have the chat box section, which you guys are doing a good job at using right now. So we will not be unmuting our mics. We will not be revealing our cameras. So what we'll do for today, because we're quite a number of us and we are still keen on you guys being able to share what you have in mind, share your comments and questions. So we will do that through the chat box. And how we'll tackle that is that we just after the presentation, we will look at the comments and questions. and select the ones which have been upvoted, or select very interesting questions. So if someone has written a comment or a question and you're also very intrigued by it, or you'd like a response to the same, please do upvote it and we will tackle it during the Q&A session. Now, on to the guest of honor today. Let me call him the guest of honor. So let me introduce you to today's speaker. He's our GraphQL guru. He's the only other person who's on camera with me. So this is Joe Ngethe. He is a JavaScript engineer. He's the only person who was on the poster, so you can't confuse him for anyone else. He is a senior software engineer in Twiga Foods Limited. Had a very great contribution in building our vendor platforms as we know them. That's for us internally and also for you guys. He is a known solution giver for those of us who've worked with him. He has a great sense of ownership and diligence in what he does. I think it speaks for himself. That's why he's a senior in what he does. So he's really backed up a lot of people in their professional journeys, and he's really charted the way forward in how we build our products. So without further ado, Joe, the platform is yours.
Thanks, Jess, and thanks everyone for being here. It's an honor to kickstart this series. It will be a series, and yeah, I'll just take it away. I'm going to share on my screen, and we're going to take it from there. So again, thank you everyone for being here. I hope you can see my screen. And you know, a bit about myself. You know, I like old cars. People call them old cars, but I like to call them classic cars. I like technology, and you can talk about investments. I'm still learning how about investments. Also like traveling and meeting new people, learning about how they go about their culture, food, etc. Also contribute often to the open source communities. I do meetups, talks, things to do with React, design systems, and GraphQL. I also hold a Nairobi GraphQL meetup. You can check it out, where I normally give talks and invite even other people as well. You can follow me on Twitter at African Sinatra. Don't ask me why that handle. Anyway, so so this talk, I'd like to just clarify a few things before I go into this talk. So this talk is not a comparison between REST and GraphQL. These are two great technologies, and there's no one solution fits all. You just have to choose which one will help you deliver whatever you want to deliver to your users or your customers. And there's no one that's better than the other. It just it depends on a lot of things, and of course it's not a rant on REST. So this talk also is just it will take you through how why how Twiga adapted GraphQL and why, and then we are going to do a really quick and contrived crash course on GraphQL for some of Twiga uses this, and then some learnings along the way. So I'd like to start with the story. So this is a long time ago, but it's around 2017, and the business is still at an early stage. is trying to, figure out things, what it can offer. And as you can imagine, a startup at this stage needs to ship fast. You need to make iterations fast, ship fast, and at times even like start all over again. Um, there was uh, there was a backend, a monolith backend, which was built in Flask, uh, and it didn't do much. It had like maybe 3, 4 modules, um, and then even if it was week, maybe even 2, just to onboard and be productive, make changes, start, be confident to make changes and make contribution. Um, then we had like one client, a mobile app. It was just one, and that was it. There was nothing else. Again, also the mobile app was really simple. It did like 2 things. Uh, then the other thing that I can remember was there was this cron job that we used to send out at a specific time to send out reports via email. Execs would like to keep track of some metrics. So yeah, and that was it. And then the engineering team, I think it was around 3 engineering members. So as you can see, it was relatively small, and we are just getting started. But even at this stage, in this small, we had challenges. Um, so one of the discussions I remember was we needed to, break out services into smaller chunks, smaller services that did 1 or 2 things, and that was it. So this would make it easy. When they were small, it could be easy for them to be managed, to make iterations and ship. So the thing that came up was microservices, and with microservices, you still need to build like a gateway where your clients or things that will be consuming your API, that would be their entry point. So when we're doing some research, GraphQL just happened to pop up. And one of the things I remember, it was relatively easy to build up like an API gateway with GraphQL. Um, so just to define what an API gateway is. An API gateway is it sits between your client and a collection of backend services. In this case, microservices, and it just acts as an entry point. And what it does, it just acts as a proxy that delegates API calls to the underlying services. So again, you can also add other things like auth, rate limiting. You can add like things like analytics, etc. And then you can also easily add new services. Um, and then also you can also like remove them, maybe deprecate them or retire them, but the clients will still discover them just in one place. So the findings showed that GraphQL can do this in a relatively easy way. So this is around late 2017, and we chose to go with GraphQL. But at this time, just to give another history about GraphQL. So GraphQL was first implemented by Facebook, and it was open sourced in September 2015. This is 2017. So as you can imagine, it's relatively new. So even like the information that was out there was still like scarce, and the ecosystem was growing. when you talk about tools, documentation, tutorials, all these things. But also the selling point of GraphQL, it was enticing because it was something different, something that we are not used to, or we've never seen before, especially to the clients when building clients. So some of the advantages, that GraphQL talked about is GraphQL is a formal specification, and when you have a formal specification, it's like when you want to implement something, you have to follow, word by word. Uh, and what that does is like you remove guessing games. For example, if I want to do like a put, you can have a debate. Should the status code be a 200 because it's okay, or should you return like a 201 because the resource was created? Or if, let's say, someone tries to access this resource and they don't have the right permission, should they get like a 401 because they are unauthorized, or 403 because it's forbidden, or maybe a 404? Maybe they shouldn't even know that it's there. So, you remove these guessing games, because it really defines how things should work. And again, it's open source, because if you find yourself guessing, you can always contribute, and people don't have to guess again. So what this does is like you start having meaningful discussions that would impact your users. For example, can we, I don't know, like cache this? Can we lazy load this? With something that would eventually impact your users, um, the user experience. And some of this, we can go on and on. I'd need to go off the screen. I'd need more space just to, but from the offering was really good. It was something different, and yeah. So these are some of the things that we caught our eye, and we decided to use GraphQL. So, and with that, I'd just like to give like a crash course on GraphQL itself. So for some of us who have never used this. So one thing I'd like to point out is like GraphQL, at least for me, when I first had it, I sort of thought like, is it like they say like it's a querying language, and it's like SQL or something, but it's not. They're totally different technologies that do totally different things. They serve different purposes. So GraphQL sits between clients and the server. And it doesn't, at times we think like it will solve like some of the issues, for example, like performance issues, inter-service communication, but it doesn't. GraphQL, with this paradigm of, as we'll see later, of a schema. So a schema is its promise to the client, and this is really powerful because you're always sure like what it will give you, even before you make an. It would require some data. The query itself, you can see like that the query and the response, they're similar, uh, and this is because of things like and again, so for example, let me just go back. So another thing for with GraphQL is like you only get what you ask for. So here we asked for the name, the height, and the mass, and that's what we got, right? But here you can say I just want a name of the hero, and that's what you'll get. And I remember seeing this tweets by someone way back, which got a lot of attention and discussions going on. But again, it helps in some way if you think about it. Consider if you're making like an UI, and most of the time, if you're making like a responsive application, or maybe you have a mobile app and a web app, most of the time because of real estate, they'll have different data needs. Some will ask for more data, some will ask for less data, and this is advantageous. So the whole concept of GraphQL revolves around what we call a schema and resolvers. So a schema would define the shape of your data. And this is a hard constraint. For example, in here from the previous example, we had a hero, and then we have like a name, a height, and a string. And then we use these scalars to define these types. For example, you're using a string, a scalar type, and an integer. And the exclamation just denotes that this data point is not nullable. It cannot be null. It has to return something. Then we have a query type. So a query type is a special type. It's a root type. So we normally have 3 root types. We have a query, a mutation, and subscriptions. So queries are ways to get data. Think of them like gets. You want to get something. And then we have mutations where you want to make a crude operation. And then we have subscriptions, which deals with something totally different, like data. And then the resolvers themselves would, it's how you get, they're just functions. And then these functions would return some data. And this data, again, it has to, is constrained to the schema. So in this type, we're just returning an array of objects. And inside the object, we have a name, a height, and a mass. So you can see like the results and the schema, they're fairly similar. And again, one thing you'll notice is that GraphQL is database agnostic. You don't have to use like a database. So for example, here I'm just using data fixtures, but you can do anything. You can, more often than not, when you're building like rewards and applications, you'll need a database, but you don't necessarily need to, to use a database, as long as you return the data in the shape of the schema itself. Yeah, and then there are built-in scalar types. So here we have strings, integers, we have floats, booleans, and strings. But GraphQL also allows you a way to define custom scalar types. But also there are libraries out there that have created lots of scalar types that you can think of. And one of them is the GraphQL scalars package. So here it has a lot of scalar types that you can think of. Rather than reinventing the wheels, you can use them. So so we've seen a schema and resolvers. So what's remaining to make this runnable is to package this together into something that's callable or runnable. So here, there are different ways that you can do this, but here I'm using GraphQL tools with the helper function, which makes this to runnable. So, and now we have a schema. And what's remaining now, we can create or compose a query that we can run against this schema. And even without having some kind of fancy, some server, we can use against the execute function. Then when we run this, we can see the data that's been retrieved. So I mentioned like GraphQL is database agnostic. Another thing is that it's supported in almost every programming language that you can think of. You can go to graphql.org and see some of the servers implementation of GraphQL on their end. Again, if it's not there, you can roll up your own, because again, remember, it's a specification that needs to be followed. You know, if you come up with with your own language, you can always build your own server. Yeah, so another thing I'd like to talk about, so we've talked about to create a gateway. If you've used something like Apollo Federation or Apollo Router, there are similar ways, but the other ones, they tend to be vendors of creating like this super graph from underlying sub-services. So what happens is that you know, you have this, you sort of like compose these smaller schemas into one gigantic schema that you can, you know, you can call in one endpoint. So normally what would happen, you have sub-services living in isolation. They're oblivious even of each other. But you have this one gateway or endpoint that you expose. Can consume. And it has its own advantages. So, you know, you can query data in a single request rather than having, for example, let's say you have a product service, a user service, a review service. You'd have to, you know, make calls, keep track of all these endpoints, and call them individually. So you'd have with schema stitching, it helps with having like smaller services that can be developed in isolation, and can be evolved as well. So this would mean like even when you're scaling up your teams, it will be easier for someone just to concentrate or on board in one service, uh, you know, without having to know about everything else. Another thing is that, you know, you can integrate with a third party, a service that you didn't necessarily build. It could be, you know, something else, maybe from a partner, or, you know, an open source tool. It doesn't matter really. You can also add it on there and have it accessible. And then again, you have, you know, your teams working in isolation with autonomous, you know, engineers, or the teams can, the specific respective teams can be, you know, they know their domains and they know, you know, what they need to expose, etc. So they can work in isolation. Again, I mentioned there are different ways to use build a gateway with GraphQL upon a router, upon a federation, and of course, you're talking about schema staging. You can have a look at those examples as well. So let's have a look at one of these. So for example, let's say we have a product service schema. Let's say we have different services, and in this case, we have a product service, and this is its schema. So it's fairly straightforward. We have an ID, name, SKU, and a price. And then we have another service that's, let's say, a review service. Let's say you want to gather reviews of a product. And its schema would look something like this. So you have a type, which is a review. It has an ID, a rating, a comment, and a date. And then notice this product type, which overlaps between the two services. So product review service at this point, it doesn't offer anything unique in terms of the product itself. Um, it's just that you need for it to get a review of a certain product, you need to sort of store like a reference of the product itself. Uh, think of it as a foreign key if you think about that databases, but it doesn't know about products. It just knows about this ID thing, which we'll look at later. Just keep in mind this. And then, so product service would send its query like this. So if you're making a request to product service, this is how you'd query for that data. And then on review service, this is how you'd query for this. And then now, if you build a gateway, you can query for all this data, the combined query. You can see it has a product query and a reviews query. So this is, we've composed these two small graphs into one gigantic graph that we can query in one place. So these services are living in isolation. They don't even know about each other. Maybe they have their own DBs, but the gateway unifies the two, such that sort of like they live together. But the gateway is smart enough to know where this data lives, and it delegates this to the underlying services. And I think I've done a lot of talking. I'd like to do a really quick demo here. Let me see. So here I have, if anyone hasn't worked with GraphQL before, so GraphQL, this is another advantage of GraphQL. It comes with this thing called Graphical, which is like an explorer of GraphQL. And what it does is like an interface where you can interact with your API. So here you'd have this docs thing, and then you can sort of see what this thing does, right? So here we can see we have a field, hello, and then it returns a string. So what we can do here, on the right here, we can run our query, say hello. And then we have this button here where we can run the query and return the data. Here we can see the data. So the interface of this is you can sort of you have here you can pass variables, and here you can pass request headers as well. So this as is, it's it's just a hello world, and it's not so useful. So what I'd like to do is sort of merge or create like a gateway really quick. So, and for this I'll use third-party open APIs that also you can play around with that. One of them, we have this API for Star Wars, fans of Star Wars. You can check this out. So this is an open API that you can play around with. And again, this is a service that lives in isolation. So here, we are getting some people and we are getting some data back, right? And this is where it lives. This is the remote URL. Again, there's another open API, fans of SpaceX. This is a SpaceX implementation, which is open source. And here again, you can run some queries and get some data back. So at this point, we have our own server, which is running locally here. What I'd like to do is create this schema such that we can query them here. So as it is right now, you can see on the docs, we only have one query, which is a string, right? Then locally, what I'd like to do is add this to, let me just copy this. Then I'm going to create some schemas here. And then I have this utility function which just takes arrays of remote schemas, and then it introspects them and returns the schema. So there are different ways of building this, but this is, here we are just using introspection. So here we are just looking, passing the local schema, and the local schema is the example that we looked at. So here I'm just defining a hello in a string, and the resolver, again, remember I talked about it doesn't care where you get your data from, as long as this function returns have here running at the moment. So here, what I'm going to do, I'm going to add this onto this schema. So here I'm going to merge this. Something is going wrong. Okay, let me see. Something just had to go wrong. Oh, okay. I think I need to await this. Thanks to TypeScript. So what I've done here, so remember our API as it was, it just had a hello string. So what I've done here, we should be able to make queries of SpaceX within our GraphQL server. So I'm just going to refresh this. And then now let's check the docs. Boom. And you can see here we have a lot of other things which came from the SpaceX thing. So, and here, other than just the hello screen, we can, query for other things as well. So let me see what we can run. Let me just copy some here. And you can see we have data. We did not implement this, this functionality. We just merge this stuff. This is something someone else built. So let's go ahead and add this one for Star Wars. I'm just going to add it here. Give it a save. I'm not sure if it restarted. Something broke again. I'm not sure. Let's see. Something going on with the API. to do. Anyway, we can try something else. Let's just go and look at. Let's look up for something else. Let's try the GitHub one. I don't know if you can use this. Yeah, we can't. Rick and Morty. Okay, that seems to work. Let's see what you can query here. So episodes. Okay, this seems to work. Let's see if we can run it on a server. Yeah, and we have that on there. Cool. So, and with that, essentially what we've done, we've just created an API gateway really, really quick, even though it's not us who build this stuff. So just to recap what we did, so this is sort of how an API gateway, specifically an API gateway works. So you'd have this gateway, so and then you have sub-services, and all the gateway does, it acts as a proxy layer that delegates requests through to the underlying services. So in this case, when we are making requests on our gateway, it was delegating to the SpaceX, Star Wars and Rick and Morty APIs, because it doesn't know this data, but it knows where the data lives. And this is similar to what our setup is. So this is more or less the same. So you have different clients that make requests to this gateway, and then you have a number of services that it delegates the request to. It's smart in that sense. So one thing maybe you might have noticed, especially when you're working with microservices, is you might have noticed like it's not so useful because more or less you need like a relationship between data. And I'd like to talk about another concept called type margin. So type margin, think of it like this. Remember our review service and our product service? So we had reviews, and then we had this foreign key that referenced the product. So that lives in review service. And then we have product service. Now the product service knows about all this data about products. So on the gateway, what you want to do is to make a query like this. If you look at that query, where the entry point related to a product. In this case, an ID, name, SKU, and a price. And normally what happens when you can add a configuration because these two types, they have overlapping types, which is a product type in this case. You can add a configuration onto your gateway. And essentially what you're saying, your margin types. And one of the biggest advantages of GraphQL, in my opinion, is introspection. So introspection is being able to tell even ahead of time, even before you make a request, what it can give you. And this is how it smartly knows what type it is. So in this piece of code is saying, whenever you encounter a product, merge it. And what you're saying here, you can pass like a configuration. This is manual merging. There's another preferred way of automatic merging, but here we're just saying merge products, and then you'd have another resolver, a product by ID, and then you select product ID, which is like an argument that's required for this query, and then it would smartly merge these types, and then you'll be able to do to make queries like this on the gateway. So one thing to note about this, this is it has a performance issue, and what's typically known as a n+1 problem. So if you make like nested queries, the nested entities, they will be resolved one by one. So let's say you're asking for 10 reviews, and each review has, you're requesting for product inside it. You'll face some performance issues because this will be resolved one by one. There's another way that you can tackle this, which is by batching. And essentially, this uses data loader behind the scenes. And then instead of having a resolver that accepts one argument, you have a resolver that accepts an array of arguments and returns an array of products. These are some of those things that you need to be aware of because you'll face them. Unless you're using like libraries that take care of this for you out of the box, such as Prisma. If you've used Prisma, you don't even need to think about this stuff. They come naturally. There's also another way of going about this, which is schema extension, which is again not the best way. So the way you can extend a type, you can say review, and essentially what you're saying here is the review type should also include a product type, which is manual, and there are better ways, but it's nice to know about them. Yeah, so one thing I'd like to also talk about, because I see time is not on our end, with GraphQL, there's a lot of tooling around GraphQL that is really powerful, and really, it's beneficial in the long run. For example, I'd like just to highlight just two as we go along. The first one is GraphQL CodeGen. If you're building a front-end app or even back-end as well, you need to use GraphQL CodeGen. And what this does, it creates a type-safe client that you can use to query against your backend. If you want to create hooks and all these kind of things. And with REST, you might have like to make a request and then sort of manually inspect what it returns, and then which is error prone, and you'd have lots of exceptions, cannot read something of undefined or something like that. So with GraphQL CodeGen, you'll catch this in your dev flow even before you build your app. You'll catch these bugs early enough. And then as you go along, when you're evolving your app, you need to know of any breaking changes detect changes. Maybe you want to receive a schema change notification, and keep, operations consistent. You don't want to remove a field and maybe it's being used. Um, at least, be aware that you're removing this, and then, you can say, yes, I want to remove this thing. Another thing is GraphQL Hive. If you want to monitor performance and make iterations, notifications, and all these kind of things, you can check out GraphQL Hive. There's also an alternative, which is a paid solution, Apollo Studio as well. You can check those things out. I'd like to quickly wrap up because I see time is not on our side. So, when you're building GraphQL APIs, some of the things you still experience along with REST, you still experience them. For example, performance, and it might even be a bit harder even in GraphQL because, for example, caching is not so straightforward. Uh, in GraphQL, you have one endpoint where you make everything, all your requests. With REST, is relatively easy because you have dedicated resources or endpoints, uh, which work well with, even with web caching APIs. So, you still have to solve for these issues. And if you really and you truly want to scale, and or if you don't want to break your bank for paying for, databases and cloud resources, you need to cache stuff, and preferably on the edge network. But GraphQL, the landscape has changed. It improves productivity. And then I think at once, front-end engineers, back-end engineers, they finally have like this common thing that they can talk about, the schema. That's the common thing. You don't have to like each other, but once you design this schema, then say, yes, this is what you're going with. That's our promise to each other, and that's what we should get. um, and then also you want to monitor, don't forget security. I talked about it doesn't solve lots of issues that people think that that it will solve for. And again, the ecosystem has improved throughout the years. I think it's easier nowadays to build some of these things, because there are lots of toolings, lots of documentations, etc. And then I saw this tweet the other day by this guy, and I think they were just arguing about GraphQL. And what he said is, I think I don't know what they tried to do. So he put like GraphQL between the server and the database, but GraphQL lives between the server and the client, not between the server and the database. Don't do that. Um, yeah, and then in closing remarks, I mentioned I hold GraphQL meetups. You can check out Nairobi GraphQL and join.
Amazing, amazing. Thank you so much, Joe. Guys, help me appreciate Joe. He's done an awesome, awesome job. I've learned so much. Please use the reaction button. It's there for the purpose. Let's give Joe his flowers. I think he's done a pretty awesome job during the session. And now we'll open up the any questions. We're about 6 to 7. Yes, the reactions coming on chat via the reaction button. It's an open session. So first I'll respond to RKT. You asked if we will get access to the session's recording. Yes, a recording will be made available. All of you signed up using your email, so that is the mechanism we will use to avail the recording for you. We have a few humorous comments around the demo, how the demo got struck again. Paul. Yeah, it's true. But that's how we know it's live. I'll narrow into the question. So first question we have Joy. Joy asked, is the yoga graphic what you've just shown us? What's commonly known as a GraphQL playground? Joe?
Yes, yeah, so that's it's a playground. Essentially, what happens is that you don't want this in production, but when you're developing, you need to, play around with the APIs. Yeah, so that's that's graphic, graphical. But there's a new tool. Actually, I did the design, but there's a new graphical. I'll share the link. I think we saw it in one of the, I think it was the swapping. It has a more polished design. Uh, and but yeah, generally that's it. So the playground, it just lets you to um, see the docs, make some requests, just play around with it. But yeah.
Awesome. Thanks, Joe. Your question has been answered, Joe. You can drop a thumbs up. Next question, we have Oliver. Have you ever tried GraphQL subscription?
Yes, myself, I have. I have, but they're not so trivial, especially if you want to do them at scale for me. But like I said, GraphQL has changed over the years. There are other alternatives that you can explore that does more or less the same as subscriptions. I'll share a link. One of them is known as a stream. So a stream and live queries. So it's we use something called um, a directive, and normally has is you do a query as live. And what this does, whenever that piece of information changes, the client would get notified in real time. Also, you can have a stream. A stream is such that think of it as a buffer. If you watch like on YouTube, you see like it's buffering, you say it's buffering because the information comes as stream in real time. That also serves as the same thing. So to answer your question, yes, I have, but they're not. At least for me, I didn't find of course, I'm sure like there are people who use them at scale, but they can be tricky at scale. Uh, and also, I mentioned you can use uh, at live query and at stream. And I'm going to paste those links on the chat.
Awesome. Thank you, Joe. We have a comment here from Jean. He said the Coded seems a very nice tool, insightful. Yeah, thanks, John. On to the next question. We have one from Stephanie. She said, hi, when the resolver for query returns the wrong type, where does this fail? Or do we see the error upon request?
Yes, so that will fail on request. So GraphQL itself goes in three stages. The first one is validate, pass, and execute. So it will fail in the execute phase because that's when the resolvers will be called. So if you say you're returning a string, but here, I don't know, like an object, that's where be able to know like this type is not that it's not aligned with the schema, so it will fail in the requests or execution phase.
Awesome. We have a few comments. Maybe I can read a few. Jean again says that was a great discussion. Bombo said bananas on him, so look for him. Then there's someone with a question on internship opportunities. I think that has been answered, but I'll iterate. You can check out our website. It's very, very updated. So whenever opportunities, you will to see that under the page. on to the next question by Jean. If the GraphQL makes is easy, how to go around the single endpoints which might be so clustered compared to REST APIs? Should I read that again, Joe?
I'm trying to sort of understand that. So if the GraphQL is easy, how to go around the single endpoints will be so clustered compared to it. I'm not sure I get this question. Sorry, Jen. Do you mind sort of rephrasing that? Thanks.
Yes, John, you can attempt to rephrase, then we will come back to the question. We'll move on to Theo. He's asked, what happens when the schema is updated, but the client doesn't have the updated schema? That is, addition of a new field to a type.
Well, what happens to the client? So if the client hasn't updated, most likely it's not using it. And therefore, you know, if anything, unless you remove a type, that's when the client would fail if you haven't updated the schema on the client. But if it's a new field, the client is still not using it. But a remove of a schema or a type, the client will fail, hasn't updated.
Next question, we have Stephen. In GraphQL, is there a way to protect the data that it's not visible openly in production? Consider a banking app where the request and response may need to be hashed or encrypted.
Yes, there are different ways of this. Again, so we looked at, for example, things like, so here you have different things. So maybe you want just not to return data inside. For example, you can mask. You can do something like GraphQL Yoga, which has this thing of masking. For example, a password, something like that. You just don't want it in plain text. And also you can add like permissions. For example, if it's a password, you only want it to be maybe visible if it's the owner, but you can easily mask or encrypt the types themselves.
Okay. We have another comment and question from Stephen. He says, thanks for the talk. And his question is, GraphQL, is there to protect the data? Sorry, I think I actually read this one. Let me move to the other one. That's Laban. Yes, this is a really awesome session. I enjoyed and I've learned. Does any framework work with GraphQL or only front-end frameworks?
I'm not sure I understand the question, but just to clarify, GraphQL is it's sort of like a backend, but it works on the front end as well. So in terms of frameworks, I don't know if you're talking about front end frameworks. You can use this. You can use React. You can use Vue. You can even use Svelte. Whatever you use, there are ways of dealing with this. And then there are clients that make it run. For example, you can use Apollo client, you can use useQuery, you can use GraphQL request. There are lots of options on the backend. Even if you want to be like an app, sort of like a full stacky kind of way. If you look at, I don't know if you've heard of, I forgot the name, but if you wanted like to build like a front end, a full stack app, you can even use Next.js API routes to have like a server, GraphQL server running on there as well. Yeah, so it works for both front end and back end, but on the front end, it's mainly consuming the data, and the back end is how this data is built and the return.
Okay, thank you, Joe. I think you answered that pretty well. We are 5 minutes past time. So I'll take one last question for anyone. I think you were able to answer Bernard's question very well. So the last one would be Jean's casting clarity on his question. And he said, sorry, I was texting fast. Does the single clustered endpoint in GraphQL make it easy compared to REST APIs, separate endpoints? Does it get easier with time to avoid confusion?
Yeah, I think it makes it easier. So it's relatively easy, for example, because you don't have to think like which endpoint, for example, if you want to put, make a put, post, whatever, or you want to fetch a certain resource. With REST, normally they have dedicated endpoints, unique. So you need to sort of keep track of this, all of this on the front end and make the relevant one. But with GraphQL, you just need to know like one endpoint. For example, you can have slash, just one endpoint and that's it. And of which with Cogen, you don't even need to think about it. You just add it as a configuration once and forget. And then books that, fetch the data. So it's easier, if that makes sense.
Oh, it does. He didn't answer his for frameworks, but Bernard, he's given us where to reach him. So in the interest of time, please allow us to at least say we can confidently end the first Twiga Text webinar. Thank you, Joe, so much for sharing your wealth of knowledge around GraphQL. Guys, can we please give him a hand once again with your reactions? Just let's appreciate Joe for the 1 hour he's been able to squeeze in his wealth of knowledge to enable us to understand a lot more around GraphQL and even painting the context of how we approached it in Twiga. So this brings us to the end of today's webinar. Thank you all so much. Again, thank you for showing up. Thank you for being a lively audience. We have to have another one in December. So keep your eyes for the next poster. So just around the same time, and we will be sharing the recording, and we'll also be looking to hear your feedback on how the session was, what we can improve. As I mentioned, this is our maiden session, and we are so happy that a lot of you was able to attend in quite some fullness. So please keep an ear out. As I mentioned again, we will share the recording, and we will also be keen to hear what you think about the session, what we can improve, and even the different topics that you're interested in learning more about or hearing more about within our, be across engineering. It can also be across product. As I mentioned, this is the Twiga Tech Talks. It is a forum by the Twiga Tech department. So please to share whatever it is you feel like you would really hearing from us. So Joe has shared where you can reach him. So Bernard, we don't wish to cut you off. He has given you access. He has shared that you can reach him through his Twitter. And I think you guys can also reach him through LinkedIn. It's very available. So thank you all once again. Have a wonderful evening and see you in the next one.